Hello students, it's good to see you, at least see you virtually here. And we have come to the end of chapter 7, which is multiplying fractions and mixed numbers. We are not doing lesson 10. Lesson 10 is going to be one that we're going to skip, and we're going to move right into the end of chapter review and study guide and all those things. So what I want to do is I want to flip around and show you and get right to it, because we're going to go through the questions in your book. So you're going to go in your book. I'm going to go online and I'm going to take a look at what's here. And you can see that this is your book online. So you can go into your Think Central account and you can go to the student edition, the actual ebook, and you can type in the page number at the top. And we're going to start on page 488. So oh, no, we're not going to start on 488. We're going to start on page 480. Hold on one second, guys. Hold on one second. Let me flip back. I was on the wrong page to start. 483. So let me just kind of use this as an opportunity to show you. So we're going to touch this. And we're going to then type in 483 and the arrow. And then we're going to go to it. So there we go. So the chapter 7 review. I want you to circle numbers 1 and 2 because we're going to do items 1 and 2 on this page. All right, so put a circle around them so you know which 2 to study. All right, the first one, let's talk about it. It says Mrs. Williams is organizing her office supplies and there are 3 open boxes of paper clips in her desk drawer. Each box has 7/8 of the paper clips remaining. How many boxes of paper clips are left? Shade the model and complete the calculations below to show how you found your answer. So we want to find the actual answer, which goes here, and then simplify that into how many full boxes in terms of a mixed number. But they want us to use a model as well. So let's move over here and take a look at this. So what I'm going to do is put my notebook here, and we're going to take a look at this and see if we can figure it out. So take a look just at number 1 at the top. We'll get down here in a moment. So I should probably try to keep this covered just so you're not distracted. There we go. All right, so like I said, doing the best without my smartboard. So 3 times 7/8 because that's what we have as our problem. So what we're going to do is we're going to take 3 models that are divided into 8s. Don't mind look beautiful? They look so much nicer than the ones on your screen, right? No, but they're going to do because it doesn't really matter that they're perfect. And we are going to shade in 7/8 of each one. So I'm going to shade in 1, 2, 3, 4, 5, 6, 7. And then I'm going to do that over here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Doesn't matter which 7. So what I'm going to do is I'm going to have 7/8 3 times. Now, we know already, in the beginning of the chapter we didn't know, but now we do, that we can actually take this and do this. We can take 3 and make it 3 over 1. Because we have 3 wholes, so the denominator is 1, and we're going to cut them into 8ths, and we're going to take 7/8 of each one like we did over here. Okay? All right, so what we're going to do is we're going to multiply 3 times 7, and that's going to be 21, and 1 times 8 is going to be 8, and then we have an improper fraction. So your first answer that you would type in right there is going to be 21. You would actually write it in your book. So go ahead and follow along with me. Write that in your book as 21/8. Okay? Down here, what we're going to do on our notebook is, or in your book, you can actually do this in your book if you want to put the work on the side. We're going to simplify this by dividing. So we're going to take 21 and divide it by 8. Okay? Can 8 go into 2? No. Can 8 go into 21? Yes. So we're going to have a 1-digit answer. 8 times 2 is 16. 21 minus 16 is 5, because I can do that mentally. And is 5 less than 8? Yes. Since there's no digits to drop down, the 5 is my remainder. I write it as a fraction over 8. So 2 and 5/8 is my answer, and I put that right here. Now, if I were to figure that out over here with the model, if I were to take one of these pieces and erase it and put it here, let's just do that. I'm going to take one of these pieces, erase it, and I'm going to put it here to make that whole. and I'm going to take one of these pieces, and I'm going to erase it, and I'm going to put it over here, and I'm going to make that a hole. Don't I get 2 5/8? 2 holes and 5/8. 1, 2, 3, 4, 5 out of 8 of the third one. So the model proves the math on the side. All right, very good. Now we're going to move to number 2. So let's read on the screen what's going on with number 2. Okay, this one's interesting. It takes a little bit of time. We have to persevere. Diana worked on her science project for 5 1/3 hours. Gabe worked on his science project for 1 1/4 times as long as Diana. Think about what that means. He worked longer than her because we're multiplying by a mixed number. Paula worked on her science project 3/4 times as long as Diana. Think about what that means. 3/4 times is smaller than 1 whole, so that means she worked less time than Diana. So we have to figure this out with some true and false. Now, look over here. We already were thinking about what they're going to ask in a moment. So for 2A, 2B, 2C, and 2D, we have to pick true or false. And we are not going to play Price is Right. It is not, all right, let's just guess and see if, and hope for the best. We're not doing that. So look at 2A. It says, Diana worked longer on her science project than Gabe worked on his science project. Well, Diana worked for 5 1/3 hours. So let's look at this here. So this is A. Diana worked for 5 1/3 hours. And it says here that Gabe worked 1 1/4 times as long as Diana. So I have to take 5 1/3 and I have to multiply it by 1 1/4. Now, technically I don't have to solve it because I can just think about what happens when I multiply Diana's number by 1 1/4. Aren't I going to get an answer that's bigger than 5 1/3? So if it says here Diana worked longer on her science project than Gabe worked, that would be false. Okay? Now, the answer is false, and I'm going to write it on the side over here, but I'm going to solve it to prove it. So if you're ever not sure because you're not sure, you can always go through and solve this problem. So on the side over here, let's actually do 5 1/3 times 1 1/4. So let's do this. So 5 times 3, remember the rule, is 15, plus 1 is 16, and we're going to make that 16 over 3 because we keep the denominator. And then we're going to do 1 times 4 is 4, plus 1 is 5, and we're going to make that 5 over 4 because that's the denominator. So then I'm going to multiply 16 times 5 and 3 times 4. Well, 16 times 5 is, what is that, 80? I'm just going to do that because I think I did that in my head correctly. And then 3 times 4 is 12. So 80 over 12 is an improper fraction, so I have to do a division problem. So then over here, I have to keep moving this. The flap to this is kind of a pain. All right, so I'm going to do 80 divided by 12 and see what I get. All right, 80 divided by 12. So 12 times 5 is 60. That's too small. 12 times 6 is 72. That works because then I'm going to have 8 left over. 8 is less than 12. So my answer is going to be 6 8/12. Now, I don't have to worry about simplifying it right now because all I need to know is it true that Gabe worked or Diana worked longer on her science project than Gabe? No, it's not true. Gabe worked longer because his mixed number that we're multiplying by Diana's mixed number is going to make her mixed number bigger than the 5 1/3. Okay? Very good. Now let's move on to the next one. Let's see Paula. Now we already talked about Paula. It says Paula worked less on her science project than Diana worked on her science project. Well, if Paula worked 3/4 times as long, like it says there at the top, 3/4 is smaller than 1 whole. So look here. What's going to happen when I take Diana's number again and multiply it by a fraction less than 1? Would you say that it's going to be less? Paula worked less? That's true. She did work less because we know it already because we're multiplying 3/4 times that amount. So what I'm going to do is I'm going to take 16 thirds again because I know that that's my Diane amount, and then I'm going to multiply that times 3/4, and I'm going to see what I get. What's 16 times 3? That is what? 48 over 12. Well, 48 divided by 12 is going to be smaller than 80 divided by 12. So let's do that on the side. Let's pick some space over here. I don't have room. Where do I want to do this? The good thing is you can just kind of pick some space. 48 divided by 12. All right, so 12 times what is 48? 12 times is 4, isn't it? 12 times 4 times 2 is 8. Yep, 12 times 4 is 48 with no remainder. So my answer is 4. Okay, so up here, when I take a look at this, 5 1/3 times 1 1/4 equals 6 8/12. And then 5 1/3 times 3/4 equals 4. Okay, and so far I've answered false and true. All right, now let's look at the next one, which is C. Gabe worked longer on his science project than Paula. Well, we know that already. Look, here's Gabe, and there's Paula. So we already answered it. So actually the part C is true because we already figured out that Gabe worked longer than Paula. He was very diligent on his work and she didn't work quite as long. Maybe she didn't need to work as long. Maybe she was able to understand it quicker and get it done sooner. But regardless, the question says, did Gabe work longer? True or false? And we say that part C is true. So look, if I were to take this 5 1/3 times 1 1/4, I would just say 6 8/12. And then over here for Paula, it would be the same numbers that we did here. And we're going to say that this is going to be true. Is that what we said? True. So we have false, true, true. So make sure you fill that in. And now the last one, part D, is where we have to actually, let's read it and say, Gabe worked longer on his science project than Diana and Paula combined. Okay, so that means I have to take and figure out Diana and Paula, combine the two. So here's Diana and Paula. What's Gabe's amount? Oh, I have something wrong here. This should not say 1 1/4. I don't know why I have that in there. Okay, because that's not Gabe's amount. Gabe's amount, I must have been distracted there. That amount should be 6 and, what was Gabe's amount? 6 8/12, yes? All right, so I have to see if these two add up to that. So what's Diana? We already know that she's 5 1/3. And what's Paula? She's 4. Well, I already know that that's not, I don't have to do any work. Do you know why I don't have to do any work? Because Gabe worked for 6 8/12 hours. But Diana and Paula, if I just add the whole number part, it's already 9, which is well above 6. So that one's going to be false. So Gabe can't brag that he worked longer than both of the other kids. All right, so it's false, true, true, false for those problems. Okay? And that takes care of questions 1 and 2. All right, we're going to move on to question 4 on the next page. So I'm going to click the button up there, and that's going to be page number 484. Don't get seasick, guys. Don't get seasick. All right, so as I move on to that page, like I said, I'm holding one iPad, filming with another, and we go from there. Okay, so question 4, let's look at this one. Question 4, so you're going to circle number 4 on this page, number 5, and number 6. So we're going to do this whole page, 4, 5, and 6. So number 4 says, Franny put 2/3 of her music collection on an MP3 player. And while on vacation, she listened to 3/5 of the music on the player. How much of Franny's music collection did she listen to while on vacation? All right. All right, so what we're going to do is we're going to take a look at this problem. So when I look at this, we have to figure it out. Well, it says draw a rectangle with array with 3 rows. That would be the 3 in the denominator of 2/3. And how many columns? What's our other denominator? Our other denominator is 5. So when I look at my picture there, we're going to have this picture right there. We're going to have 3 rows across, okay? So we're going to have 1, 2, 3, and then we're going to have 5 up and downs. 1, 2, 3, 4, 5. So make sure you fill that in. Shade how many of the rows gray? So what's my numerator for my rows? Well, 2/3, so my numerator is 2. So I'm going to shade in 2/3 gray. 1, 2. It doesn't matter which 2 rows, but I have to shade 2 of them gray. All right, so there we go. So I circled the 2. Now it says shade how many of the gray squares black. They're talking about the squares now. Be careful. It doesn't say the columns, but we know we have to shade in how many columns? We have to shade in 3 of the columns. Now it says to use black. So what I'm going to do is I'm going to use the blue pen just because that's what I have. So I need to shade in 3/5 going up and down. So I'm going to shade in 3/5. 1, 2, 1, 2. Sorry, because I have to count that as 1 column, 2 columns, 3 columns. So there's 3/5, right? So I shaded in 3/5 up and down and 2/3 across. So how many of the gray squares did I shade in with my blue, which is supposed to stand for black? So let's see how many there are. 1, 2, 3, 4, 5, 6. There's 6 of the squares. So my answer for that one would be shade 6 of the gray squares black. So for 4C, we're up to 6. All right, so I'm going to fill this in here because I want to make sure I'm filling this in. So how many of the rows were gray? 2. How many of the squares were black? 6. All right, and then we have to find the answer, which is Franny listened to how much of her music collection while on vacation? What fraction? Well, if it's a fraction of a fraction, 3/5 of 2/3, then we have to multiply. So let's go through and do that. So 3 times 2 is 6, and 5 times 3 is 15. Now 6/15 is not there. Do you know why it's not there? Because 6/15 is not simplified. So we have to simplify 6/15. So what we're going to do is we are going to take that and we're going to say, think of your factors for 6 and 15. Well, 3 times 2 is 6, and 3 times 5 is 15. I heard 3 for both of them, so I'm going to divide them both by 3 and see what I get. 6 divided by 3 is 2, and 15 divided by 3 is 5. So I get 2/5. So how much of her music collection did she listen to? I get 2/5. Is that one of my choices? There it is, 2/5. So make sure you circle 2/5 and make sure you know how you got that. All right, let's go to question number 5. All right, question number 5 is Logan bought 15 balloons. So we have to draw 15 balloons, but how do we arrange them? Oh, fifths. 4/5 of the balloons are purple, so we need to put them into rows, 5 rows. And we're going to circle 4 of those rows. So how many of the balloons are purple? Draw a model to show how you found your answer. So what we have to think about is what we said over here. So if we're going to do 4/5 of 15 right here for number 5, we have to think 5 rows and circle 4 of those rows. So let's look at this and see what we have. So I made 5 rows going across and I numbered them for you. And I made sure I kept adding to my rows. So I put the X's going down and then I kept adding till I got 15. And I have a nice array. And then I had to circle 4 out of the 5 rows. And then I have to figure out how many there are. So how many are there? 3, 6, 9, 12. So my answer is 12. Now, is there a way to do this without an array? Of course there is. Because I can take this and do what? 15 over 1. And I could say 4 times 15 is 60. 5 times 1 is 5. So I would have 60 over 5. 60 over 5 is improper, so I can do division. And I know that 5 can go into 6. So I'm going to have a 2-digit answer. 5 times 1 is 5. 6 minus 5 is 1. Check mark it, bring down the 0. 5 times 2 is 10, and there's no leftovers. So the answer is 12, and that's what we got here. So 12 is my answer. I can use division to get it, or I can use an array. All right, that takes care of number 5. All right, now let's go to number 6, because we have number 6 here. I want to show this to you. So number 6 is Kayla walks 3 2/5 miles each day. Which of the following statements correctly describes how far she walks? Mark all that apply. So you know that there could be more than one answer for this. So when you get to number 6, I want you to take a look at this. What we're going to do is we know that Kayla walks 3 2/5 of a mile each day. So she's getting good exercise. What I want to do is I want to change that to an improper fraction so that I can multiply it as a regular fraction. Just treat it like it's a regular fraction. So what I did is I did my rule, and I said 5 times 3 plus 2 for my numerator, and then I kept my denominator. So I got 17/5. Then what I have to do is I have to look at each one of my choices. So the first one for A, it says 4 days. Then it says 7 days for B. It says 10 days for C, and it says 31 days here. And then it gives us different totals. So if you look at the totals are in the middle of the statements, each one. So what we're going to do is we're going to multiply this number, as in improper, times the number of days to see if that equals the miles. And if we get those answers, then we fill in the circles for them. If we don't, then we don't fill it in, and we don't select them. So let's go through and see if we can figure it. We'll do one, and then you can do the rest on your own. All right, so 17/5 times 4 over 1. So I would have to do 17 times 4 on the side. So somewhere over here, I would do 17 times 4. 68. So I'm going to get 68 over 5. Now when I get 68/5, that does not match what they tell me there. They're giving it to me as a mixed number. So that means I have to divide it. So I have to take 68 and divide it by 5. Can 5 go into 6? Yes, so I have a 2-digit answer. 5 times 1 is 5. 6 minus 5 is 1. Check mark it, bring down the 8. 5 times 3 is 15. 18 minus 15 is 3. 3 is less than 5. Check mark it, but I'm all done with digits. So 3/5 is going to be my fraction part. So I'm going to say my answer is 13 3/5. Right? Looks good, right? So then I check and see if that answer is here. Is that answer here? No, it says 14 2/5. So for A, I am not going to pick A as my answer. So what I have to do is I have to go through the other ones, and I have to treat them all the same way. Notice I took all of my whole numbers and I put them over 1. 4 over 1, 7 over 1, 10 over 1, 31 over 1. That way we could multiply using our fraction rule of multiplying the numerators times the numerators and the denominators times the denominators. All right, sounds good. So I'm going to let you guys go with that, and you can fill these in and check them, and then at some point I'll give you the answers so that you can check them and make sure that you have your study guide done correctly. All right, let's go to number 7. The next page, let me flip my book here so I can follow along, and we're going to take a look. So on the next page, which is going to be page 485, let me click 485, click the arrow. Okay, so we're going to circle number 7 on this page, and we're going to circle number 9. Circle number 7 and circle number 9. All right, so number 7, this one here looks hard, but we're going to make it nice and easy. So write each multiplication expression in the correct box. We're going to do this without doing any work. We want to find whether the product, and we know that means multiply, the product is equal to 4/5, whether it's greater than 4/5, or whether it's less than 4/5. So equal, greater, or less than. And it's always being compared to 4/5. So what we have to do is, if we remember the lesson that we learned on that, we have to look at the other number. So if I'm going to be looking to see whether it's greater than 4/5 or equal or less than, I have to look at the other number that's being multiplied. So look here. So if I'm going to take 4/5 and I'm going to multiply it by this, this is the number that I care about right here because I'm comparing it to 4/5. Well, if I take 4/5 and multiply it by 1 1/8, is that going to equal 4/5? Well, of course not, because the only way I can get it to equal it is if this was just a 1 by itself. But because it's 1 1/8, it's not going to be equal to. Well, is this greater than 1 or less than 1? Greater than 1. So if this is greater than 1, when I multiply it by this, my answer is going to be what? Greater. So this one right here is going to go there. Okay? So that one's going to go there. Now, in your book, they want you to actually write it into the right places. You can draw lines if you want. It's okay.